Hi, today we will be going over Project 4. So the first question is, what is the domain of the function where x equals the square root of 3x divided by 4 minus 7? We cannot take the square root of a negative number, so all x values that would make the number under the radical negative will not work in our domain. So we want to take all the numbers that are greater than 0 to find the domain. So now we're going to go ahead and solve this inequality. So we want to get x by itself. So what's the first thing we want to move to get x on a side by itself? We want to move the 7. So the opposite of subtracting 7 would be adding 7. And what we do to one side, we also have to do to the other. So we get 3x over 4 is greater than or equal to 7. Now, once again, we still need to get the x by itself. So what are we going to move next? Well, it looks like we've got to move that 4 because it's the furthest away from the x. So the opposite of dividing by 4 would be multiplying by 4. And what we do to one side, once again, we have to do the other. So we get 3x is greater than or equal to 28. Then we want to get x by itself, so we got to get rid of the 3. The 3 is multiplying by x, so the opposite of multiplication is division. Divide both sides by 3, and we get x is greater than or equal to 28 thirds. So the domain of our function would be x is greater than 28 thirds. Any number above that number is going to produce a positive number under the square root and therefore is solvable. Once again, we can't take the square root of a negative number without getting an imaginary number. So identify the given function. So f of x is equal to the square root of 3x minus 9 plus 4, and then we're given some graphs. So first we want to find the x-coordinate of our starting point. So we take the numbers under the radical and set them equal to 0. Because once again, anything that's below 0 or is a negative is going to produce a negative isn't going to work in our function. And that's why we get our starting point by setting 3x minus 9 equal to 0. So now we're going to go ahead and solve by adding 9 to both sides. We get 3x equals 9. Divide both sides by 3, and we get x is equal to 3. So the x-coordinate of our starting point is going to be 3. Next, we need to find the y-coordinate of our starting point. This is given to us in our equation. So if we look at our equation, the y-coordinate, or the starting point of our y, is given there at the end, the plus whatever, or minus whatever. So in this case, we have a plus 4. So the starting point of our y-coordinate is going to be 4. So the starting point on our graph has got to be 3, 4. So now we're going to go back and look at the graphs. We've got 3, 4 on A. On B, we have 3, 4. But notice that the curve is going down, which means it's going to be negative. And we don't have a negative in front of our square root. So if it was to be B, we'd have negative square root 3x minus 9. And then C, we have a starting point of 8, 4. And D, we have a starting point of 4, 9. So the correct answer is A. Now we're going to move on to estimating square roots. So to estimate a square root, we want to find the two square roots of perfect squares that the value lies between. So I went ahead and wrote out all the square roots. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, so on and so forth. So these are our perfect squares. So to estimate, we want to find two consecutive whole numbers that the square root of 35 lies between. So if we look over here on at our square roots, the square root of 35 lies between the square root of 25 and the square root of 36. As you can see there. Therefore, it would be between 5 and 6. Okay, now we're going to estimate the square root of 74. So the square root of 74 lies between the square root of 64 and the square root of 81. Therefore, the estimate is between 8 and 9. Okay, now we're going to move on to what is the domain of the function. So f of x is equal to 6 over 36x minus 72. We cannot divide by 0. Therefore, any x value that makes our denominator 0 is not in our domain. Sorry, my animations aren't quite popping up on this one, but we've got 36x minus 72 is equal to 0. Because once again, we can't divide by 0, so we're just taking the denominator and setting it equal to 0. Then we want to solve, so we're going to add 72 to both sides. And we get 36x is equal to 72. Then we want to get x by itself, so the opposite of timesing by 36 would be dividing both sides by 36. And we get x is equal to 2. So now we know x cannot equal 2, because if x equals 2, then our denominator would be 0, and we can't divide by 0. And thus, all the numbers but 2 are in our domain. So if we were using set notation, we would put negative infinity, comma 2, and we'd put a parenthesis versus a bracket because it can't include 2. And then union with parenthesis once again because it can't include 2, 2, and then positive infinity. Let's go ahead and solve the equation. 1 over y plus 8 plus 1 over y squared plus 5y minus 24 is equal to 3 over y plus 8. So the first thing we want to do is go ahead and factor that second denominator, the y squared plus 5y minus 24. So we're going to break down the y squared to y times y. Break down the 24. We can break it down to 1 and 24, 2 and 12, 3 and 8, or 4 and 6. We're going to go ahead and put our y's in. Then we're going to go ahead and try our 6 and our 4, because those are our closest numbers together. And then do the O and the I of FOIL. Oh, first determine our signs. We can either have a negative positive or a positive negative, because our sign is negative. So then we have y plus 6 and y minus 4. So we get negative 4y plus 6y, which is equal to 2y, which is not what we're looking for. So we're going to go ahead and try our other numbers. We've got 3 and 8. Then do the O and the I of FOIL. If you're looking for help on this one, please see the recording on FOIL and factoring. So we've got the outside and the inside that we're going to multiply. So we've got negative 8y, and then 3 times y is positive 3y. Negative 8 plus positive 3y is negative 5y, which is the opposite sign of what we wanted. So we're going to keep the numbers, but we're going to try our other signs. So we're going to put a negative on the 3 and a positive on the 8. So once again, if you end up with a negative of what you want, you just switch your signs. So we get the O and the I. The outside is 8 times y, which is 8y. The inside is negative 3y. 8y plus negative 3y is 5y, which is what we wanted. So therefore, we know it factors to y minus 3 and y plus 8. So now we're going to go ahead and look at our other denominators in our equation. And notice that we have a y plus 8 and a y plus 8. So in order to get it the same as that middle one, we've got to times it, both of those, by y minus 3. And whatever we do to the denominator, we also have to do to the numerator. And remember, the whole reason we're doing this is because we can't add unless we have common denominators. So we're going to do y minus 3 times y minus 3 times y minus 3 times y minus 3. So on that first one, we do y minus 3 times 1, which is just y minus 3, over y minus 3 times y plus 8, plus 1 over y minus 3 and y plus 8, which is equal to 3 times y minus 8. I'm using the distributive property there. If you need help on the distributive property, please see that video. So we've got 3 times y, which is 3y, 3 times negative 3, which is negative 9. So we have 3y minus 9 over y minus 3 times y plus 8. So now notice that we have the same denominator all across on all three parts of our equation, or all three terms. So because of this, we can only work with the top now. In other words, we're basically multiplying y minus 3 times y plus 8 times the whole entire equation, and therefore getting rid of the denominator or canceling out the denominator. So now we can just work with our numerator. Y minus 3 plus 1 is equal to 3y minus 9. Then we can go ahead and combine like terms. So we get negative 3 plus 1, which is negative 2. Y minus 2 is equal to 3y minus 9. Subtract y from both sides, so we can get y on one side. And we get negative 2 is equal to 2y minus 9. Then we want to go ahead and move the 9 to the other side to get y by itself. So we're going to go ahead and add 9 to both sides. We get 7 is equal to 2y. We want to get y by itself, so we've got to get rid of the 2. Divide both sides by 2. And we get y is equal to 7 halves. And that would be our answer. Okay, our final problem. Determine the vertical asymptotes of the given function. So we've got 1 over 3y squared minus 18y plus 36. So the first thing I notice when I look at this equation is that I've got a 3 in front of my y squared. So whenever I see a number in front of my y squared, or my x squared, or whatever variable you have that's squared, you want to see if you can take out that number in all the terms in the denominator. So, can I divide 18 by 3? Yes. Can I divide 36 by 3? Yes. So I'm going to go ahead and pull out that 3. So I put the 3 on the outside. 3y squared divided by 3 is just y squared, or 1y squared, which is just y squared. Negative 18 divided by 3, that'll say negative 24y divided by 3 is going to be negative 8 plus 36 divided by 3 is 12. So then we want to go ahead and factor the y squared minus 8y plus 12. So we go ahead and list out all our factors, put a y in each of our parentheses. Now we want to choose the factors on the 12 closest together first. We have our 3 and our 4. Choose our sign. It's a positive 12, so we can either choose positive, positive, or negative, negative. Our sign right there is a negative, so we want to go ahead and use the negatives. Do the O and the I of FOIL. Outside, y times negative 4 is negative 4y, plus negative 3y is negative 7y, which is not what we wanted. So we're going to go ahead and change our numbers. So we do the 2 and the 6. Do the outside and the inside. Outside is going to be negative 6y, inside is going to be plus negative 2y, which is negative 8y, which is what we wanted. So now we've got our factors right there. So now we want to determine the vertical asymptotes of the given function. So the vertical asymptotes, remember, are going to occur when our denominator equals 0, because our denominator cannot equal 0. So that's where our vertical asymptotes appear. So we want to go ahead and set our equation equal to 0. Now we can go ahead and cover one side, because anything times 0 is 0. So we're going to cover one of those, because if we get y minus 6 to equal 0, then the whole equation is going to be 0. So what number for y would make that equation 0? If you need to solve, go ahead and add 6 to both sides, and we get y is equal to 6. Okay. Now we're going to cover the other side, and we've got y minus 2 is equal to 0. What number for y is going to make that part of our equation 0? 2. So we get our two answers are y equals 6 and y equals 2. And this is where our vertical asymptotes appear. Thank you for watching. Please be sure to complete Project 4.